Hello, again Rajesh Kumar from AIC. Last class we have discussed about the chain isomerism as well as positional isomerism. This time we are going to discuss about the ring chain isomerism and other structural isomerisms. Ring chain isomers. In this type of isomerism, the isomers differs in respect of the ring size of ring as well as chain of the molecule. Take one example here. Alkenes, very common phenomenon of unsaturated hydrocarbon, alkenes and alkynes. 2-butene. 2-butene. It is one of the molecule. It is an open chain structure and having double bond within the molecule. But its another isomeric form could be here. Cyclobutene. Cyclobutene. In case of these two molecules, one is a cyclic structure, another is a open chain structure. That's why both have a different stability, but that's why they have a different physical as well as chemical property. One exhibits the property of open chain structure, another exhibits the property of the ring structure. Ring structure molecules are considered to be less stable, though it is a 4-member ring. That's why it is less or least stable, better to say here. This is called ring chain isomerism. Last time we have discussed about the positional isomerism. In case of positional isomerism, we forgot to discuss something about which type of molecule will exhibit or will not exhibit the positional isomerism. Here always remember carboxylic group, aldehyde group, nitrile group never exhibit positional isomerism. Positional isomers are also called regiomers. Regio means position. Okay. Next one is your functional isomerism. It is a type of isomerism in which isomers have different functional group but have the same number of carbon, same number of hydrogen and same number of other atoms or group present within the molecule. Functional isomers, functional isomers exhibited by so many molecules. Take the example of alcohol. Alcohol and ether both are the functional isomers. CH3, CH2, OH. This is ethanol. And isomeric form of this one is CH3O CH3, ether. Both have the same carbon number, both have the same hydrogen number, but both have the different functional group. One is have the OH group, another is ROR group. One is called alcohol, another is called ether. Both have a different physical as well as chemical property. That's why it is called functional isomers. Or this phenomenon is called functional isomerism. Another example is aldehyde. And ketone. Both are two different molecules, but both have a different functional group. These are called the functional isomers. Take another example here. Carboxylic acid. And ester. These all are the functional isomers. Since they are functional isomers, they have the different functional group, it is quite obvious that they would have the different chemical properties as well as physical properties. So these are called the functional isomerism. Last time we have discussed about some structural isomerisms like chain isomerism, positional isomerism, functional isomerism, and ring chain isomerism. This time we are going to discuss one of the important isomerism, that is called metamerism. Metamerism is one of the important structural isomerism, but this isomerism is exhibited by those functional groups which are polyvalent, means their valency is more than one. Here the isomers differs in respect of the size of R. R means alkyl group, means number of carbon atom present on both sides, on both or more than one valency of the functional group. As for example, take the example of ether, a traditional example of the metamerism. Here ether is CH3, CH2, CH2, O, CH3. It is called methoxypropane. Okay, so it is an isomeric form. Another isomeric form is this one is here, CH3, CH2, O, CH2, CH3. In both sides of oxygen, oxygen has two valency, it is divalent. Both valency are going to be satisfied by the two alkyl group. In both cases, number of carbon is same, number of hydrogen is same, number of oxygen is same, but in both cases, the size of R is quite different. Size in both cases, number of carbon present on both sides of the oxygen is quite different. So this is called metamers. Another example, amine. This is called N,N-dimethyl propanamine. Another isomeric form of this one could be here, CH3, CH2 and CH2, CH3, CH3. N,N-diethyl methenamine, or better to say N-methyl N-ethyl ethanamine. In this case, at least two R are different, two alkyl groups are different. This is called metamers, and this phenomenon is called metamerism. So, in case of metamerism, number of carbon on both sides of the functional group, or both or more than one valency of the functional group is quite different. This is called metamerism or metamers. Take one more example. CH3, C double bond O, CH2, CH2, CH3. 2-pentanone as well as CH3, CH2, CO, CH2, CH3. This is called 3-pentanone. In both cases, carbonyl group is present or oxygen group is present, either on position number 2 or position number 3. This is an example of position isomer as well as metamers. Since both are occurring together, it is more metamer rather than position isomers. So it is metamer as well as position isomers, both having there. This is called metamerism or metamers.